Let's consider gradient. The first thing that should come to your mind is what is a gradient? So basically, gradient is actually denoted with this symbol. So if you see this symbol, you should know that you are considering what? Gradient. Let's say we have gradient of vector A, and they said vector A is actually given to be AXI plus AYJ plus what? AZK. And we are asked to calculate, or we should find the gradient of vector A. What will you simply have? You have your gradient represented in this form. Now, what's the concept behind gradient? If we want to get the gradient of a particular vector, what we do is we partially differentiate each component with respect to their magnitude. So what we are saying is, for the gradient of A, the concept is very simple. The concept is we are partially differentiating what? I with respect to its magnitude. What's the magnitude here? X. So we are differentiating I with respect to each magnitude plus differentiating what? J component with respect to what? Its magnitude Y, plus we are differentiating what? K with respect to its magnitude Z. So we have differential of K with respect to its magnitude Z. Now, what do we do next? We multiply with our given vector. So we are multiplying what we have here with our given vector, which is what? AXI plus AYJ plus what? AZK. Now, looking at the multiplication of the vector, you are seeing that we are simply having a what? A dot product. A dot product. So what's that telling us? We are going to multiply what we have here with our given vector with the concept of what? Scalar product. Are we together? Now, take down the definition of a gradient. So take down, a gradient is a scalar point function. A gradient is a scalar point function derived from the vector point function. Derived from the vector point function. So basically, what is this telling us? This is basically telling us that gradient, when we are considering gradient, we are considering what? We are considering scalar point vector, and that scalar point vector will be converted to a what? A vector what? A vector function. That's the meaning. Now, if we want to expand this, the first thing that will come to your mind is, how do we expand this? Remember, when you are expanding this, you are applying the concept of what? Scalar product. So expanding this will simply what? Expanded, this will multiply everything. This is going to multiply what? Everything. And this also is going to multiply what? Everything. What we are doing is we are applying the what? The principle of what? Multiplication by expansion method. Now, if we apply that concept, we'll simply have our gradient to be, let's use partial I, partial x to expand. That will simply give us what? Partial what? Partial ax I dot what? I divided by partial what? X plus, go over to the next parameter. We are using this to multiply with what we have here. And if you do that, that will give you partial what? Ay I dot what? J divided by partial what? X. What's the next one? The next one is AZK. And if you do that, you simply have partial what? Partial AZ I dot what? K divided by what? Partial X. Now we are done with the first parameter. Let's go back to the second parameter, which is what? Partial J of what? Partial Y. We are using partial J of partial Y to expand all through. And if you do that, this will simply give you what? Partial what? AX. We have J here, so we have J dot what? I divided by what? Partial Y plus partial AY. Then we have J dot what? J divided by partial what? y plus what do we have here? This is partial k and this is what? AZK. So no, we have this multiplying with what we have here, and that will give us partial what? AZ, then this is J dot what? K divided by partial y plus. Now we want to use this to expand all through. If you do that, we'll simply have partial what? AX. In this case, we'll now have K dot what? I. So this will be what? K dot I divided by change in what? Z plus partial what? A what? This is the next one. Our interest is this. So we have this, we use this to multiply with what we have here. We'll have AY, and that will give us K dot what? J. This will give us K dot J divided by partial what? Z plus, and what's the last parameter? We are simply seeing partial K divided by what? Partial Z multiplied by AZK, and that will give us partial AZ K dot what? K divided by partial Z. Now remember, from our dot product concept, the concept is very simple. And what's the concept? The concept says I dot I is 1, I dot I is 1, I dot J is 0, 0, then you have 0, 1, 0, then you have 0, 0, what? 1, telling you that your diagonals, it is what? Equal to what? 1. What does that mean? This is simply telling you that when you have common parameters multiplying themselves together, that gives you 1. Look at what we have here. This is I dot I. So we have this to be what? 1. So we have 1 multiplied by what you have here. You are simply having what? AX changing what? X. Now look at the next parameter here. This is I dot J, which is what we have here. And what's I dot J is 0. So 0 multiplied by every other parameter here. This will give you what? 0. This also will give you 0 because we have I dot K. I dot K here is what? 0. Now, what's the next one? We have J dot I. You can see that our interest is now just the dot product concept. Are we together? Now, if we apply the concept here also, this will be 0. And 0 multiplied by every other. So if you have your diagonals to be 1, you will simply have that your gradient of vector A, you will simply have that what? Your gradient, which is gradient of A, will simply be partial what? Partial AX divided by X plus partial what? AY divided by what? DY plus what? Partial what? AZ divided by what? DZ. So what are you seeing? You are basically seeing what? The partial derivative of the vector with respect to what? The magnitude. Here you are seeing what? Partial derivative of the vector with respect to the what? Magnitude. Here you are also seeing what? Partial derivative of what? The vector with respect to what? Magnitude. So what is that telling you? That is telling you that when you get the gradient of a vector, the gradient of a vector, you will simply have a scalar as your answer. Look up, this is a vector. Why is this a vector? Magnitude and direction. What are we seeing here as our answer? We are just seeing what? Magnitude without a what? Direction. So that's telling you that if you calculate for the if you calculate for the of a vector, gradient of a vector, you will simply have a what? A scalar. And if you get the gradient of a scalar, if you are to calculate the gradient of a scalar, then you arrive at what? Your answer should be what? In vector. Are we together?